Modern soap has come a long way. Not only does it fight grime and keep things hygienic, but it also smells pretty amazing. It can come in a variety of shapes and textures, but how is it made? The first step in soap production involves selecting suitable plant-based oils. In the recent past, animal fat was used that was obtained directly from slaughterhouses. However, this was soon replaced by plant-based oils such as olive oil. Not only does this eliminate impurities, but it also results in milder and skin-friendly soaps. The quality of the olive oil depends on the quality of the olives being harvested. Selection of the optimal harvest time along with careful handling is crucial to obtaining a high-quality oil that's sublime in aroma and taste. Olives can be harvested by hand or through mechanical means. Hand harvesting is often preferred for high-quality olive oils, as it minimizes damage to the fruit. After harvesting, the oils are cleaned to remove leaves and other debris. This is usually done using equipment such as vibrating screens. The cleaned olives are then crushed to break down the fruit and release the oil. Traditionally, stone mills were used for this purpose, but modern facilities often use stainless steel crushers or hammer mills. The crushed olives are then subjected to malaxation, a process that involves mixing and kneading the olive paste. This helps in the coalescence of oil droplets into larger droplets, facilitating the extraction of oil. Now that the paste has been primed for extraction, centrifuges are used to separate the oil. The olive paste is spun in a centrifuge, and the centrifugal force separates the oil from the other components, such as water and solids. The extracted olive oil may undergo filtration to remove any remaining impurities or particles. Sodium hydroxide, NaOH, also known as caustic soda, is commonly used as the alkali in soap production. The precise amount is calculated based on the type and quantity of vegetable oil being used. The key chemical reaction in soap making is saponification, which is the process by which fatty acids and oils react with an alkali to produce soap and glycerin. This reaction typically takes place in large stainless steel vessels. The olive oil is heated and the alkali is gradually added while stirring. This process initiates the saponification reaction. The mixture is carefully monitored to ensure an even distribution of heat and alkali. Maintaining a controlled temperature during saponification is crucial for the success of the reaction. The temperature varies depending on the specific vegetable oil being used, but it is typically in the range of 100 to 150 degrees Celsius. The pH of the soap batter is tested at various stages of the process to determine the alkalinity. As saponification progresses, the pH of the mixture changes. The endpoint of saponification is often associated with a specific pH range. Factory workers use pH testing strips or meters to monitor the pH and determine when it reaches the desired level. As a result of saponification, glycerin is formed as a byproduct. In a commercial soap production, the glycerin is often separated from the soap mixture. Glycerin is a valuable byproduct and can be used in various other industries, such as cosmetics and pharmaceuticals. After the saponification reaction is complete, the liquid soap is sprayed over a big metal roll. As it passes over the metal, the soap solidifies and a big blade scrapes it off, creating ribbons of soap. The soap ribbons fall into a hopper where an auger moves it along and sends it down a chute. The soap ribbons fall down the chute into a rolling mill, where they're mixed and compressed. Small blades cut up the milled soap into ribbons once again, but this time they're much denser. These denser soap ribbons fall down a hopper into an auger, which throws them into an extruder called a noodle plate that shapes them into soap noodles. The soap noodles are then collected into a bin, which dumps them into a mixer. In the mixer, various additives are introduced to enhance the soap's appeal. Fragrances, colorants, and essential oils are added to give the soap a pleasant scent and appearance. Depending on the intended use of the soap, additional ingredients such as moisturizers, exfoliants, or specialty oils may be incorporated. These ingredients contribute to the soap's specific properties, such as moisturizing or exfoliating capabilities. When the batch is ready, a trap door opens up in the mixer. The blades of the mixer keep turning and nudge the soap out of the door. Then it's forced through another noodle plate. This mixes up the batch a little more. It also helps break down any clumps or uneven texture, resulting in a smoother and more uniform soap. The soap is then extruded or plotted into the desired shape. This can be in the form of long bars, pellets, or other shapes depending on the manufacturing specifications. The extruded soap is precision cut into individual bars or pieces. This can be done manually or using automated cutting machines, ensuring uniformity in size and shape. The cut soap bars are then left to dry. This can be done in open air or in specialized drying rooms. Drying is essential to remove excess moisture, solidify the soap, and improve its hardness. Once the soap bars are dried and hardened, they undergo stamping. Stamping involves pressing the soap with a die or mold to imprint the brand name, logo, or other identifying marks. The final step in the soap making process is packaging. The soap bars are packaged in various ways, including boxes, wrappers, or plastic wrapping. Packaging is designed not only for protection, but also for marketing and presentation. Throughout the entire soap making process, quality control measures are implemented. This includes testing the pH of the soap, ensuring that it meets safety and regulatory standards, and conducting sensory evaluations for fragrance and texture. Moreover, because soap production generates byproducts such as excess alkali and impurities, proper waste management practices are crucial to minimize environmental impact. This includes recycling, treatment, or safe disposal of byproducts. That was all about the journey of soap, from olives on a tree branch to the product that occupies your bathroom shelves. If you want to know how toilet paper is made, check out this video. The average American uses over 100 single rolls each year, and if that statistic is taken into account, it more than well explains the revenue generated by the industry worldwide, a jaw-dropping $100 billion. So how do they make toilet paper? The process starts with collecting wood, which is done by a specialized machine called a harvester. A timber harvester machine weighs 18 tons and is pretty much an all-rounder when it comes to collecting wood in the forest. It can fell trees, delimb them, and then saw up the trunks. Its efficiency is also something to watch for, as all this takes a typical harvester less than a minute to do. It's important to note that the type of wood that's cut down for toilet paper is bad wood, i.e. trunks which are crooked or wrong. The good sort of wood would be wasted on toilet paper and is used for furniture instead. Thousands of tree trunks cut up by the harvester end up at a site where the wood is ready to be turned into pulp, the raw material for paper and toilet paper as well. But before the wood can be turned into pulp, it must be converted into chips first. The machine used for this is called a wood chipper, and boy is it a giant operation. The wood is first cut into uniform pieces and fed into a shaft at the end of which giant drums await it. These drums debark the wood, a process that removes the tree's outer layer while leaving as much wood on the tree as possible. The debarked wood is then cleaned with a water bath that washes stone and sand out of the logs. Afterward, the wood goes through a metal detector that detects any stray nails or screws that might have ended up in a particular batch. It's important to remove these as they can damage machinery further down the production process. Giant rotating knives reduce the wood into tiny wood chips. The wood chips then travel down a conveyor belt into giant stockpiles. The wood chips are composed of fine fibers that need to be further broken down to convert into toilet paper. This is done chemically in large industrial tanks called decomposers, which cook the wood chips until it's converted into pulp. During the cooking, which can last up to 3 hours, most of the moisture in the wood is evaporated. Wood chips contain about 50% moisture. The mixture is then reduced to about 25 tons of cellulose fibers, lignin, which binds the wood fibers together, and other substances. Out of this, about 15 tons of usable fiber, called pulp, result from each cooked batch. The other raw material that's used for making toilet paper is recycled paper. But recycled paper is not so simply obtained as wood is. A machine called a sorter is used to separate it from junk that can't be used in the production of toilet paper. After the junk is located into the machine, it travels on a conveyor belt where the sorter removes rubbish, cardboard, and plastic fully automatically. First, a sieve removes large refuse and cardboard. Then the recycled paper is separated from the junk through the use of near-infrared sensors. As soon as the sensors detect a piece of cardboard or junk, a blast of air sends it off the conveyor belt. This type of machine can sort 400 tons of recycled paper every day. The recycled paper is put into a giant washing machine and passes through a total of 14 stations until the fiber can be used again for new paper. If that sounds like a lot of work, that's because it is, but you'll be surprised to know that such a hectic process is still more environmentally friendly than using wood for pulp. The washing machine breaks down the recycled paper into pulp, which then passes through a sieve. The sieve eliminates tiny particles of waste from the pulp. After decomposition comes fine cleaning. Fine cleaning uses centrifugation to throw heavy waste particles, such as sand or splinters, toward the outer walls where they sink to the bottom. Finally, the pulp is de-inked by washing it with soap. This makes the color particles in the ink attach themselves to the foam, which is then skimmed off. The washing process produces a pulp that has a sludge-like appearance. To make this sludge more suited for paper production, it is treated with bleach and diluted with a lot of water. Now that the factory has its hands on pulp produced both through wood and through recycled paper, it's finally time for it to make it into actual paper. The paper machine is a 120-meter giant monstrosity that produces solid paper from pulp in 4 steps. The prepared pulp is fed onto a large mesh screen or belt called a Fordrinier wire. As the pulp mixture moves along the wire, water drains through the screen, leaving a layer of intertwined fibers on top. The water removal process is facilitated by vacuum boxes and other drainage elements, which help control the consistency of the pulp and the thickness of the paper. The wet paper sheet is then passed through a series of press rolls. These rolls squeeze out more water, increasing the density of the paper. The pressed sheet is now called wet web and contains a significant amount of water. The wet web is guided through a series of heated rollers or a drying section to remove the remaining water. The heat evaporates the water from the wet web, leaving a continuous dry paper sheet. The paper sheet is still somewhat incomplete in the sense that it has creases on it. These are removed with the help of ironing rollers incorporated into the paper machine. This long-winded process surprisingly takes only 7 seconds in real time. That's how fast a paper machine really is. The completed paper is wound around a dryer called a Yankee dryer. Next, the paper is creped, a process that makes it very soft and gives it a slightly wrinkled look. During creping, the paper is scraped off the Yankee dryer with a metal blade. This makes the sheets somewhat flexible but lowers their strength and thickness so that they virtually disintegrate when wet. The paper, which is produced at speeds over a mile a minute, is then wound on jumbo reels that can weigh as much as 5 tons. How does a paper sheet end up becoming toilet paper? Well, it all happens inside a machine called a toilet paper roller. While it's not as big as the paper machine, at 80 meters long, it is still quite imposing, and it produces about 500,000 rolls a day. Multiple large jumbo reels of paper are unwound at the same time so that their paper sits on top of each other. The layers of paper depend on whether the toilet paper is meant to be 3-ply or 2. Then, different patterns are printed onto the paper depending on the brand. Micro-embossing soon follows, which gives the toilet paper its characteristic dotted texture. Micro-embossing not only gives the toilet paper more volume, but also makes it soft and comfortable for consumers. Finally, the paper is rolled on to incoming cardboard rolls. These rolls are a little bigger than what we're used to and are cut into smaller rolls of various sizes according to the specific requirements of the market, such as standard toilet roll sizes or household towel rolls. Paper companies often maintain their own tree stands in order to ensure the quality of the paper they manufacture. The chemicals used in the pulping process are also carefully tested and monitored. Temperatures at which a slurry is cooked is ensured too by checking gauges, machinery, and processes. Completed paper may be tested for a variety of qualities, including stretch, opacity, moisture content, smoothness, and color. Another commodity that has simplified hygiene is toothpaste. You'd be surprised to know that it's been around for quite a while, and here's how it's made.